Hi everybody, Cal here with sections 1.8 Introduction to Linear Transformations and 1.9 The Matrix of a Linear Transformation. These two sections are going to introduce the last major viewpoint that we're going to have in Chapter 1. And like I said before, familiarity with Chapter 1 is the key to success in this course. So let's get to it. Starting here at the bottom of 63 and going on to 64, your book introduces the idea of a transformation, which is just another word for a function, and you've seen calculus, so you've seen functions before. You want to understand the words domain and codomain. Codomain is going to be a new word for you, as well as image and range. I would spend special amounts of time and effort figuring out how all these words differ and where they go in especially this picture, figure 2 here. How do, a domain, a codomain, an image, a range all interlink? Which ones are smaller, which ones are bigger, and so on. So you want to get that terminology down. Now, there's going to be two specific types of transformation that we're looking at here in 1.8. And the first is a matrix transformation, a transformation where the action of the transformation is given by just multiplying vectors by a matrix, as it says here at the bottom of the page. Now, the blurb here about what the range of a matrix transformation is pretty important. You should make sure you understand why that is. Just travel through the definitions and make sure you understand why they're unraveling into what they are. And work through example 1. Try to figure out what the answers to these are going to be and then follow through the solution. You'll notice that what we're kind of doing here is that we are reframing old questions in the language of linear transformations. Just transformations. We haven't talked about linear ones yet. Example 2 plays with a particular transformation. Example 3 plays with another particular transformation. We get a really stupid pun here on the left, talking about the shear transformation. Alright, now here at the bottom of 66 we'll talk about linear transformations, which are another special type of transformation. Here's our definition of linear transformations. This part right here is the definition. I may be answering a question here. At the top of 67 we talk about a couple of byproducts of that definition. Make sure you know what the actual definition of linearity is. Finally, it's alluding right here to Theorem 5 in section 1.4, which I said at the time would come in handy later. Well, here's the later. What's actually going on here is that matrix transformations are our first, and in some ways only, example of linear transformations. Okay, so example 4 talks more about a particular transformations, just kind of getting our fingers on these things. And example 5 is more of the same. These are all worth working through and kind of getting a sense of how these things work. Example 6 kind of takes a couple of these some of these notions into an application, and that's fun stuff. So 1.8 is largely about introducing matrix transformations, linear transformations, transformations in general, and then just playing with some of those concepts. 1.9 refines this a little bit. So we found out in 1.8 that matrix transformations are always linear. What we find in 1.9 is that linear transformations, under very light hypotheses, always have matrices. Example 1 is a motivating example. You can kind of look through that. And Theorem 10 is the first major theorem from this section. This is how to find what's called the standard matrix of a linear transformation. Make sure you understand what Theorem 10 is saying, and there's a little bit of extra notation folded in along here, these EI vectors, EJ vectors. The proof might be illuminating to some of you. More illuminating should be the example. I would look at example 2 and example 3 and kind of try to figure out what both of those are doing. Then we get into a few pages. This is going on this geometric linear transformations of R2. We're going into a couple of pages here of charts with kind of pictures of what certain standard transformations from R2 to R2 do and what their matrices are. You don't have to put a lot of stock in those. I want you to understand how they're getting the pictures, and it has a lot to do with Theorem 10. But beyond that, you don't need to memorize all these different transformations. That's really not what we're trying to do here. They are worth your attention, but they are not worth your memorization. After those charts, we get into existence and uniqueness questions, and we're going to have new words associated with these existence and uniqueness questions. Those words are onto and one-to-one, which are defined here on 76. You want to know those definitions, and I would know this at least one, at most one language that's being used in these definitions. That is really useful language to know. We'll spend a certain amount of time on these notions in class. Example 4 goes through telling whether a certain transformation is one-to-one or onto. Theorem 11 is kind of a partial distillation of the takeaways here. I wouldn't put a lot of stock into it. Theorem 12 is a much more full synopsis of how to tell when things are one-to-one and onto, and I would take it a step farther. I would think about what each of these means about the placement of pivots in the matrix for this transformation. Okay? So if you understand everything in the chapter up to Theorem 12, you really should be able to link a lot of the concepts that we've been talking about so far. Onto has to do with columns of a spanning Rm, has to do with linear combinations, has to do with existence questions, and has to do with pivots being in rows. One-to-one has to do with linear independence, has to do with uniqueness questions, and has to do with pivots and columns. But we'll spend more time on that in class. Example 5 is a good one. It goes through finding the matrix for a transformation, and you can tell from there whether the transformation is one-to-one, whether it's onto, and so on. That's the end of Chapter 1. At this point, I would heavily recommend that you go back through Chapter 1. But that's up to you. I'll see you next time.